Hello, my name is Mike Gonzalez. Doing here the cow eye dissection. So my eye here has been cut open. Reason why I'm holding the camera with one hand, so I had to have two hands to cut the eye in half. Is very thick muscle on the wall here of the eyeball, right here. This is very thick. It was very difficult to cut. So, some of the parts here. So my viscous humor, which is what keeps the eye shape and keeps it also moisturized, is right here. Kind of frozen a little bit, a little flash frozen. Normally, it's kind of I guess like a jello consistency. But there it is for you to see. As we go into the structures of the eye, the ones that I wanted to kind of point out that I thought were kind of interesting. The first one here is this ball-like structure. And I'll show you how it kind of sits in. It sits in right here. And this is their lens. And the lens, of course, takes the reflection of light and sends that reflection of light to the optic nerve, and that's how the cow gets its images. Also, so does the human. But the lens can change its shape. It can change from left to right. And how does it do that? Well, it does it here with these muscles. These muscles here connect to the lens, and these muscles are called the ciliary body. And the ciliary body will tug and pull and turn that lens so it can change its shape. And also within here, you see I kind of detached the inner parts of the eyeball. You have the iris, and here's your pupil, and then of course the cornea is on this other side here. But the cool thing about the iris here, this is what we see the different colors in humans, from green to brown to dark brown to blue. But they're also muscles, and they connect to the cornea, and they change the they change the shape of the pupil. And the pupil is the opening here, and they change shape to allow either, of course, during nighttime they allow for dilation to allow more light into our eye so we can see at night. If it's bright light or the sunlight, they're going to constrict and not allow so much light to go through. Also, the pupil's responsibilities for this viscous humor back over here again, to flow in throughout the eye to keep it lubricated. When you go to the posterior end of the eyeball, which I think is the prettiest part of the eyeball, you see these beautiful shades of blue and black. This is the retina. The retina here, you're going to have an optic disc. When I noticed when I opened my packaging for the eye, my optic nerve was missing. So to find the optic disc, it's a little, looks like a little dot, and there it is right there. It's right there. So that's the optic disc. In that disc, if I would pull back this retina, it would all be tied in to right there. It would be connected. Reason why, there's cones and rods in there that deter different colors and shapes, and those receptors will pick up those signals that the eye has allowed in, and it goes into the optic nerve into the brain to make an image. But the retina, I wanted to keep it attached because I think it's neat to look at. But it is a thin layer, and we can pull that back to see the back of the eye. But in humans, this is all black. Reason why is we don't have real good night vision. Unlike other animals, or especially the cow, this blue here allows for dark or lack of light to be reflected into the eye and into the nerve, and so they can see. So those are just a few structures here I thought were pretty interesting and wanted to bring of note in my video. So everybody have a good day, and Hopefully this was informative. Thank you. Bye.